Hello friends, this is lecture 6 of gamma and beta function. Here we're gonna prove the relation between the beta and gamma function. So now let's start. Before we start, please subscribe the channel if you are new to my channel. Also share with your friends, help me to grow my channel and inspire me to create new videos for you. And also hit the bell icon so that you get notified when new video will be uploaded. So now let's start. So here you can see that let me prove this one. So we know this property of gamma function, that is that integration of 0 to infinity. Just simply let me write here. So we know the definition of gamma n is equal to 0 to infinity x to the power n minus 1 e to the power minus x dx. Now let us assume that 0 to infinity x to the power n minus 1, we can consider that e to the power minus x is nothing but e to the power minus 1 into x dx, and we can also consider there is 1 to the power n, right? 1 to the power 1, again also 1. So now when there is 1, you can see when there is 1, we can consider n to 1 to the power n. So simply we can write this as, suppose n, gamma n 0 to infinity x to the power n minus 1 e to the power, suppose instead of 1 we have z x, then this 1 to the power n will be z to the power n, that is dx, right? So hope you have understood this. So now you see, therefore we can say that gamma of L, we can write 0 to infinity and x to the power L minus 1 e to the power minus zl into z to the power L dx, right? We can write this way. So now let me copy this result and let me go to the next slide. Okay, so this is what we have got. Now you see, let us multiply both sides with e to the power minus z and z to the power m minus 1, right? Then what we're going to have, that gamma L e to the power minus z, z to the power m minus 1, and on the other side as well, integration x to the power L minus 1 e to the power minus z, sorry, there was x here, it should be x, right? Just wait, it should be x, right? So x z to the power L dx, and we have multiplied dx, we have multiplied e to the power minus z and z to the power minus m minus 1, sorry, we have multiplied this on both sides. Okay, then you can write n integrating with respect to z, then we can integrate it from 0 to infinity, from 0 to infinity, right? Here we're gonna write dz, then in that case dz. So here also again one more integration will be there, that is what, just wait, 0 to infinity dz. Okay, so hope you have understood this. Now you see, so this part is the function of z only, so we can write this gamma L outside the integration, right? E to the power minus z, z to the power n minus 1 m minus 1 dz, then integration 0 to infinity, let me write the parts, function of x only, x to the power L minus 1 then dx, and next part is 0 to infinity, then function of z. So e to the power this and e to the power this, that's gonna be minus 1 plus x z. Minus z is taken common, right? If you multiply these two terms, then you should get this, right? Okay, then what you will get here, z to the power l plus m minus 1. If you multiply these two, you're gonna have z to the power l minus m minus 1, then dz. That is what we have got, right? So hope you have understood this. Now here you can see that okay, now let me copy this result. Okay, just wait, let me copy this result. So now this is the last step we have got. So here you can see in this part again we can apply this property that 0 to infinity e to the power minus ky y to the power n minus 1 dx dy is equal to gamma n by k to the power n, right? So if you use this result, right, then what you will get. Now here you see, from the definition of gamma function, this is going to be equal to, we can write gamma l gamma m, right? By the definition of gamma function, this is gamma m, right, is equal to 0 to infinity x to the power l minus 1 dx. Now you see, just wait, this part if you compare with this, here k is this is your k and n is l plus m, right? This is your l. So that's why here you can write gamma of l plus m instead of gamma n, right? And k to the power n is, k is here 1 plus x, and to the power n is your l plus m, right? This is what you will get, right? So hope you have understood this. So this is what we have used. Okay, so now you see gamma l gamma m, right? In this case let me write this gamma l plus m outside the integration, and integration 0 to infinity x to the power l minus 1 by 1 plus x l plus m dx. This part is nothing but this is equal to beta lm, right? So here you see we have already got that since you see in the previous lecture, in lecture 5, I have already shown you that beta l comma m, beta of l comma m is equal to integration 0 to infinity x to the power l minus 1 divided by 1 plus x whole to the power l plus m dx, or m plus l dx. So these things we have proved in the previous lectures. Okay, so here in place of this thing we can write, so we can write gamma l gamma m by into gamma l plus m. Here replace this by this result, then here you can write beta of l comma m, right? So this is the result we have got. So now let me copy this, let me go to the next slide, so continue from here. So this is the result we have got. Now this is beta, let me write here properly. So this implies beta l comma m is equal to gamma l gamma m by gamma l plus m. This is how we can prove the relation. We can prove the relation between the gamma and beta function. This is the relation between gamma and beta function. Relation between gamma and beta function. So hope you have liked this video, then hit the thumbs up button and share with your friends. Thank you for watching. See you in the next video. Subscribe the channel if you are new to my channel. So take care.